All right, guys, we are going to finish this double displacement and then get into our last type. So, potassium hydroxide. Potassium is a positive one, and hydroxide is one of our polyatomics. So potassium is a positive one, hydroxide is a negative one. Hydrogen is a positive one right up here, and sulfate is a negative 2. So we've got our charges. Now remember, positives have to bind with negatives. So the only other negative besides hydroxide is the sulfate group right here for potassium to bind with. Positive 1 plus negative 2. That will still give me a negative 1. So I'm going to need 2 positive ones. So I'm going to need 2 potassiums. Why is this lagging? Let's give it a minute. So I'm going to need 2 potassiums with the 1 sulfate group. Okay? And then hydroxide is going to get together with the hydrogen. Now, a positive 1 plus a negative 1, I'm going to need 1 of each. Now, in reality, this is going to simplify. This HOH is going to simplify, but I want to simplify it in just a minute. Okay? So let's balance our equation quickly first. So I've got 1 potassium, 2 potassium, so I need to double this. And the other thing I want to really look at is my sulfate group. I've got 1 sulfate group and 1 sulfate group. And then I've got 2 hydroxide groups, so I'm going to need 2 hydroxide groups, and I've got 2 hydrogen groups and 2 hydrogen groups. Okay, so let's rewrite this simplified. 2 KOH plus H2SO4, so 2 potassium hydroxides, 1 sulfuric acid will get me potassium sulfate and HOH. Should I put these 2 hydrogens together? I usually do. It makes water, and I need 2 of them, so it will give me 2 waters. So a lot of times when we are dealing with water, balance it as HOH. It will make it a lot easier, especially when you have hydroxide and hydrogens coming together. They're actually making water. Okay? So double displacement, everyone switches partners. Okay, just a little review. We talked about the diatomic elements. So there are 7 elements that occur as diatomic molecules when they appear in their elemental states in a chemical reaction. Hydrogen, oxygen, nitrogen, fluorine, chlorine, bromine, and iodine. Okay? Combustion, generic. We have a molecule made of carbon and hydrogen. Sometimes it will also be carbon, hydrogen, and oxygen as well. Then we have it burning with oxygen, and we always, always, always have carbon dioxide and water as our products, always and forever. Now, when we balance these equations, we want to look at the carbons first. So we're going to do carbons first. We're going to look at the hydrogens second, and we are going to save our oxygens for last. Okay? So, in every single one of these, I can write carbon dioxide and water as my products. Every single one. Okay, so let's look at our carbons first. We've got natural gas, or methane, burning with oxygen and creating carbon dioxide and water. So 1 carbon, I'm okay. For hydrogens, I've got 2. So 2 times 2 is 4. Do you guys agree with that? 2 times 2. And then I always need to look at my oxygens over on my product side first. 2 right here, and 2 times 1 is 2, so that gives me 4. 4 divided by 2, because they're in groups of 2, is 2, so I need 2 oxygens. Okay, let's look at this next one. I've got C2H6, which is known as ethane. It will also produce carbon dioxide and water. Okay, so let's look at our carbons first. Let's make that a better H. It's going to let me erase that. Okay, H. All right, 2 carbons. So I need to double up my carbon dioxides to get me 2 carbons. 6 hydrogens. 6 divided by 2 is 3. Okay, 2 times 2 gives me 4 oxygens here. 3 times 1 gives me 3. 4 plus 3 is 7. Can I do 7 out of groups of 2? Is 7 divisible by 2? It gives me 3.5. Can I put a half, 3.5? No, I need whole numbers. So what I'm going to need to do is I'm going to need to go back and double everything. So I'm going to double this, which would mean 2 times 2 is 4, so I need 4 carbon dioxides. 2 times 6 is 12, so I'm going to need 6 waters. Okay, so 4 times 2 will now give me 8 oxygens, and 6 times 1 gives me 6, which gives me 14 oxygens. So 14 divided by 2 is 7. Okay, let's look at this next one. I have octane. This is the primary ingredient in gasoline. When I burn it in oxygen, I get carbon dioxide and water. Okay, so let's look at my carbons first. I've got 8 of them, so I need to multiply this by 8. Okay, 18. 18 times 18 divided by 2 would give me 9, right? And then let's see, 8 times 2 gives me 16 oxygens here. 9 times 1 gives me 9. 16 plus 9 gives me 25. Can I divide 25 by 2? I can't. So I'm going to have to go back and I'm going to have to double this all. So I'm going to go back and double this all. So 2, right? And 8 multiplied by 2 is 16. 9 multiplied by 2 is 18. So I'm going to have 32. I'm going to have 18. 32 plus 18 is 50. 50 divided by 2 is 25. Okay, and then this last one, it is cellular respiration. We are taking glucose, we are breathing in air, which has oxygen in it, and we are breathing out carbon dioxide and water, right? That's what's going on in your body right now. So let's look at our carbons. 6, so I've got to do 6. 12 here, 12 divided by 2 is 6. And then here we go. The oxygens on this one can be kind of tricky. So 6 times 2 gives me 12. 6 times 1 gives me 6. 6 plus 12 is 18. Okay, so I will have 18. Now, notice I'm going to need 18, but I've already got 6 right here. So 18 minus 6 is 12. 12 divided by 2 is 6. Okay, so sometimes there are oxygens on here that you have to be aware of. Okay, so take a minute and remember we've got 5 main reactions types. Okay, we've got synthesis, which is building something. We've got decomposition, which is breaking something down. We have single replacement or single displacement, which means we are switching one element with another in a reaction. We have double replacement or double displacement where we are switching partners with two things. Okay, so everyone's switching partner. And then last but not least, we have combustion where we are taking a hydrocarbon, carbon, hydrogen, sometimes oxygen, burning it in oxygen, creating carbon dioxide and water. Okay, so those are the 5 main reaction types. Have a great day and good luck. See you. Bye.